Hello everyone, welcome to another episode of Revernos. In today's video, we will be discussing Monte Carlo simulations and object-oriented programming in Python. We will cover the basics of classes, objects, simulations, and much more. Make sure you like, comment, and subscribe, and click the notification bell so you don't miss an upload. Alright, so let's jump right in. The first thing you'll need to do is open your development environment. I'll be using Jupyter Notebooks in this video. And the first thing we need to do is our import statements. So we'll import the random library, which is what we'll be using to create our random distribution. And then the next thing we need to do is create our minnow class. So we'll type class, which is the keyword in Python you need to create a class. And then we'll have the name of our class. In this case, is minnow. Then we'll have a colon. Now, every class will have behaviors and attributes. Behaviors will just be functions, which when they're associated with the class are called methods, and those attributes will just be variables. So we're going to give our minnow class some attributes, and we'll do that via variable declarations. So we'll give our minnow a species, and we'll just set this equal to blank for now, and we'll be able to give that an initial value or initialize it later on in our code. And also each minnow will have a probability of being eaten. So we'll just say prob being eaten, short for probability of the minnow being eaten. And we'll set that equal to 0.0 for now. And once again, we'll initialize that with a value later. And when you give your attributes or these variables a value, you need to use an initialization method inside of your class. And so we can do that by typing def, which is the keyword you use to define a function in Python, or a method in this case. And it will be underscore underscore init, which is short for initialization. And then once again, two underscores. And this is a special keyword in Python also that's used for these initialization functions. And then we'll pass in self, which once again you'll need to pass in every time you have an initialization method in Python. And we're going to want to define our species and the probability of being eaten when we create our minnows. So once again, we'll just pass in those same variable names. Then once again, since we're inside of a function, we will need our colon to end that, and then we'll go in one level of indentation. And here we'll just say self, that species equals species, and self that prob being eaten equals the probability of the minnow being eaten. And so what we're essentially doing is we're saying these variables, species and probability that being eaten, which we'll access using that self keyword, and we'll set that equal to the species that is passed into our initialization method when we actually call this and create our minnows. In this class, we'll have one more function, so go out one level of indentation, and we'll have some code that handles what happened if a minnow gets eaten. So in this case, we need to determine if the minnow actually will be eaten. And so once again, since we're inside of a class, we'll need to have that self keyword. In this function, we'll define if a minnow gets eaten or not. So we'll have a chance or survival variable. And we'll just set that equal to 1 minus the probability of being eaten. I mean, there's only two outcomes for a minnow in this case. The minnow either gets eaten or it doesn't. So the chance of survival is 1 minus the probability of being eaten. And we'll need to use the self keyword to access that. Now, we need to choose a threshold for when the minnow will be eaten. So we'll just say if the chance of survival, we'll just say it's less than 0.5, which is 50%, we'll return true, which means the minnow does get eaten. Otherwise, we'll return false, and that means the minnow was not eaten. So now we can go ahead and run that cell, and now we have to create our ecosystem, which is what will contain our minnows, which is effectively what we'll be simulating. We'll be doing these ecological simulations in this case. So let's go ahead and create our ecosystem class, and I'll go through this one a little faster since we've already created the minnow class. But we'll need minnows, and we'll have a certain number of minnows. So we'll say null minnows, and we'll give that initial value 0 for now. And we'll need a certain type of minnow, which we'll just set that equal to our minnow class. And we have a species and probability of being eaten for each of our minnows. we'll just say regular minnow is the species, and the probability of being eaten, we'll say 0.6 for 60%. Now from here, we can create our initialization method, and we'll have to pass in self, num minnows, and minnow type. And once again, we'll do self.num minnows equals num minnows, and self.minnow type equals minnow type. And now that we know how many minnows and what type, we need to actually populate our minnows list. And so we'll just say for iron range, self.number of minnows. And what this is effectively doing is whatever we pass in for number of minnows, that's how many minnows we will add to our minnows list. And so we'll just do self.minnows.append self.minnow type. So now we know what type of minnow we'll be putting into our ecosystem. So we can go ahead and run that. Okay, it looks like we're getting an error there. Let's see what's going on. We forgot our n keyword. That should be for in range. And then we can go ahead and run that and we're good to go. Now we're going to create a minnow and we're going to test if this minnow gets eaten. So we'll go ahead and create a minnow class. This will be a regular minnow. And the probability of it being eaten will be our random variable. So for that we will pass in random, the uniform, and we wanted a number between 0 and 1. In uniform distribution, every number has an equal chance of popping up, and we want anything between 0 and 1. This will return the decimal number for us. And then we want to see if the minnow gets eaten, so we'll call this minnow gets eaten function. And let's see what happens when we run this. We can see this minnow does not get eaten, but then we'll see the more we run this, some minnows get eaten and some don't. That's exactly what we want in our simulation. Now that we've seen that our minnow class works, let's go ahead and create our ecosystem. We'll call this river underscore ecosystem, and we'll set this equal to our ecosystem class. We'll create an object. For the number of starting minnows, let's say 100, and then we need to pass in the minnow. So we'll just go ahead and copy this here and pass in our minnow, and then we can go ahead and run that. And we need to add an additional parenthesis at the end before that works, so add that. And now that we have our ecosystem, let's actually run our simulation. So we'll just start with a print statement saying the number of minnows at the beginning. Sorry, make sure you type everything properly. And then we will take the length of our river ecosystem dot minnows, which remember is a list that contains our minnows. We're taking the length of that and then casting it to a string so we can include it in the print statement. And we're just going to create a loop here. And we'll be using a while loop. And we'll do this for all of the minnows in our ecosystem. So while counter is less than the length of the river ecosystem dot minnows, which remember is our list, if river ecosystem dot minnows, and we're looking at this particular minnow, so we want to go inside our list and access the particular minnow we're looking at, and if that minnow gets eaten, then we're going to remove a minnow from our ecosystem, which we'll do by calling river ecosystem dot minnows dot pop, which will remove a minnow. And then we have to increment our counter to avoid getting stuck in an infinite loop. And then we can exit our loop and we'll look at the number of minnows at the end of the simulation. And once again, that will pass it to a string and we'll be looking at the length of our river ecosystem minnows list. So we can go ahead and run that. If you run that, you'll get an error, but just go ahead and remove that set of parentheses after minnows and then run that. And make sure you add an extra closing parenthesis there. And now you can see we started out with 50 minnows and ended up with 25. In case you're curious, the reason why our number of ending minnows is pretty much always half of our number of starting minnows is because we're using a uniform distribution between 0 and 1. And so on average, that will give us a value of 50. So about 50% of our minnows are getting eaten anytime. You can also use different kinds of distributions, but remember, when we're talking about the probability of a minnow being eaten, if you use a normal distribution, then there is a chance you may get a value outside of 0 or 1, but that will also depend on what you set as your standard deviation. Thanks for watching, and we have a lot of great content on our channel, so make sure you like, comment, and subscribe, and check out some of the playlists we have on this channel. So thanks for watching. Please like, comment, and subscribe, and click the notification bell so you don't miss an upload, and then I'll see you in the next video.